All right, let's jump right into this explainer on the brand new HTTP query method and honestly how it's about to fundamentally shift the way we build REST APIs. If you've been working with APIs for a while, you know the struggle. For a long time, we've basically been stuck trying to fit complex data fetching into methods that just weren't designed for it. It's like trying to fit a square peg in a round hole. But finally, a brand new method has arrived to solve this exact problem, and I am incredibly excited to walk you through it today.
We've all stared down this absolute nightmare of a URL, right? You're building an e-commerce platform, your users want to find a laptop. Simple enough. But then your front end allows them to filter by category, minimum price, brand, stock status, ratings, the whole shebang. Suddenly, your clean GET request turns into this ridiculously long, messy string that literally looks like a cat walked across your keyboard. It's ugly, it's incredibly hard to read, and dynamically generating it without throwing errors is a massive headache.
So, here is our roadmap for today. We'll start with the problem with GET, look at why POST isn't perfect, enter HTTP query, see query in action, ask if GET and POST are dead, and wrap up with adoption and the future.
Section 1. The problem with GET. Look, stacking nested filters into query parameters isn't just an aesthetic problem. It is a massive structural one. When your URL gets this huge, it often blows right past the character limits set by browsers. And worse, proxies, servers, and API gateways sitting in the middle, they'll simply block or drop the request entirely if the URL is too long. Plus, when you have these heavily nested, complex filters bouncing around in the URL, natively caching that data consistently becomes incredibly difficult.
So, developers being developers, we looked for a quick duct tape fix. We thought, hey, why not just send a JSON payload in the body of a GET request? It kind of sounds logical, right? You keep the method as GET, but you hide all the messy filters in a clean JSON body. Well, the problem is HTTP semantics intentionally never defined a request body for the GET method. GET was strictly designed to be read-only without a body payload. So by forcing a body into a GET request, different software behaves completely, wildly unpredictably. Some servers might accept it, sure, but a lot of them will outright reject it, which fundamentally breaks your existing HTTP infrastructure.
Moving on to Section 2. Why POST isn't perfect.
Now, to really understand why the industry workaround is flawed, we have to grasp a massive concept in system design: idempotency. It's a big word, but it just means that if a request is idempotent, you can send it to the server 1,000 times, and the end state of the server will remain exactly the same as if you sent it once. It doesn't change or create data. Now, GET is naturally idempotent. POST, by default, is not. POST assumes you are modifying or creating new resources.
So what did we do? We started using POST for complex searches in tools like GraphQL, Elasticsearch, and heavily within enterprise REST APIs, simply because it allowed a body payload. But here is the fatal flaw with that workaround. POST is fundamentally not safe or idempotent. When you use POST just to read data, you are essentially lying to your network architecture. Imagine the sheer panic when there's a network blip and your client automatically retries a POST request. Because the network assumes POST means create data, a retry could theoretically result in accidental duplicate resources being created, even if your specific application logic was just trying to do a harmless search.
It all boils down to this. HTTP methods carry meaning, not just syntax. They aren't just arbitrary labels. Proxies, gateways, and caching layers absolutely rely on that meaning. They need to know your true intent. If a proxy sees a POST request, it naturally assumes a state change is happening. It doesn't know if it can safely retry the request or cache the response, and that leads to massive inefficiencies. We had a real fundamental mismatch on our hands.
Section 3. Enter HTTP query.
This is where things get really cool. What query does is perfectly marry the safe, cacheable semantics of GET with the heavy payload capabilities of POST. Just like POST, query allows you to send a request body, which means you can send those massive, complex JSON or XML filters cleanly. But just like GET, its primary action is strictly to read. It is fully idempotent. That means it won't ever modify the server state, making it incredibly easy and safe to cache, and totally safe to automatically retry if the network drops.
Now, to maintain this pristine server state, the HTTP query method draws a very hard line in the sand regarding what it's designed to do. It explicitly allows search operations, complex filtering, pulling analytics, and generating reports. However, it absolutely blocks state modifications. You should literally never use query to create users, delete resources, or update data. It is for reading deeply and safely, period.
Section 4. Seeing query in action. So how does this actually build out practically, say in a Node.js and Express environment? Well, because the standard is so new, popular frameworks like Express don't actually have native built-in support for an app.query method just yet. But the implementation is super straightforward. You essentially just set up a manual handler. When your Express server receives a request, it checks if the method string strictly equals query. If it does, it extracts all those complex category, price, and brand filters directly from the request body, just like a POST request, and then securely returns your filtered laptop data.
But there's one super vital piece of the puzzle to make this all work smoothly. The server can send back an accept query response header. Think of this header as a transparent handshake. It tells the client exactly what body formats the server is actually capable of handling for query requests. In our case, application/JSON, but it could just as easily be XML, protocol buffers, or binary data. It keeps the communication between client and server incredibly clear.
Section 5, are GET and POST dead?
It's the absolute elephant in the room right now. Is GET really dead? Have we actually reached the end of the line for the most famous HTTP method in existence?
The answer is a resounding no. GET is still very much alive, and it remains the absolute gold standard for what it was built for. Look, if you're doing simple fetches, pulling up a specific resource like user number 10, executing basic parameter searches, or handling straightforward pagination, GET is exactly what you should be using. It's fast, it's universally supported, and it's perfect for simple reads.
Okay, but what about POST? Did query entirely dethrone POST?
Again, no way. It is absolutely vital to understand that query only replaces POST in the specific scenario where POST was being abused. Actually, let me rephrase that. If you were using POST simply to read data just because you needed a request body, that is exactly where you swap in query. But POST is still the absolute king for real server state changes. Please do not use query to process a credit card, or you're going to have a really bad time. You will continue to use POST for user logins, file uploads, processing payments, creating new resources, executing commands, and triggering webhooks.
Finally, Section 6, Adoption and the Future. So here's the reality check on the current landscape as of July 2026. The official specification, RFC 1084, was just published last month in June. The ecosystem is still very much emerging. Right now, if you're working on internal enterprise APIs where you control both the client and the server, and your tech stack supports manual implementation, you can safely start using Query today. However, for public-facing APIs, you really need to hold off. Browsers, API gateways, proxies, and client libraries are still updating. Switching your public APIs to Query right now would cause massive breaking changes for your users, and nobody wants that.
But make no mistake, over the next few years, HTTP query is going to become the undisputed standard, finally fixing a problem we've been hacking our way around for over a decade. So I leave you with this. Is your API infrastructure and your engineering mindset actually ready for the transition? Audit your enterprise projects, identify exactly where you're abusing POST, and start architecting the future today. Thank you so much for joining me on this explainer, and keep building.